Hi everyone. Notes 5.6 are a review of solving linear trig equations. And if you notice right here, there's a list of steps of what to do. So this is pretty much review. We've already done this a bunch of times, but I'm just kind of like formalizing it for you. So this is the problem that we're solving, and it's on the domain of 0 to 2 pi. And question or step A says to determine the period of the new domain. We don't have to worry about the new domain. So let's find the new period. So, all right, so let's find the period. So the period is always going to be 2 pi over k. And if you take a look right here, we can see that the k value is 4. So we're going to say that this is 2 pi over 4, which is pi over 2. And since we are going from in a domain of 0 to 2 pi, we can see that there are going to be 4 periods within our domain because pi over 2 fits into 0 to 2 pi 4 times. So there are 4 periods here. Now we need to determine a u substitution. So our u substitution right here is going to be based on whatever our angle is. So here we're going to say let u equal 4x minus pi over 3. Okay, so in doing that right here, our new equation becomes cosecant of u plus 6 equals 1 minus 3 cosecant of u. And then in the next step, we're going to isolate the trig ratio. So using this equation right here, we're going to isolate the trig ratio. So I'm going to add 3 cosecant u to 1 cosecant u, so I get 4 cosecant u. And then I'm going to subtract 6 from 1, and I get negative 5. Which means that cosecant of u is negative 5 over 4. But I don't want cosecant, I want sine. So I'm going to switch this over to sine. And I'm not going to say 1 over sine is negative 5 over 4. I'm going to say sine of u is equal to negative 4 over 5. Okay? Then step D says to find the related acute angle, and this step is written in bold because it's so important that you know that we are going to find the related acute angle first. We have to find this related acute angle. This related acute angle is for u, not for x, okay? So to find a related acute angle, remember we have to use a positive ratio. So right here, this means that u is going to be u sub r, we'll call this u sub r for the related acute angle, the inverse sine of 4 over 5. So let's calculate what that is. So here, I'm going to find the inverse sine of 4 over 5, and so that tells us that our related acute angle is about 0.93. But I'm actually going to store this in as a variable because this is not my final answer, and so I want to use this exact value and not a rounded answer. Okay, so then it says to determine all possible values of u in one period. Well, if you look right here, we got to a point where this says right here, sine of u. So for u, our period is just 0 to 2 pi, right? 2 pi is our period because the k value is just 1, nothing's changing. So we're talking about one period of u, not one period of x. So we are not talking about this pi over 2 period right here, okay? And because sine is negative right here, we're looking at quadrants 3 and 4. And in quadrant 3, we know that our related acute angle is 0.93 right here. And in quadrant 4, we also know that our related acute angle is also 0.93. So we know that within one period, u sub 1 is going to be like our first answer is going to be in quadrant 3, and that's going to be pi plus u sub r, or pi plus 0.93. And then our answer in Q4, which is going to be our second answer, is going to be about, this right here we know is going to be 2 pi minus u sub r, which is going to be approximately another value. So let's figure out what these values are in our calculator. And I'm actually going to call this right here u sub 1, okay? And this is going to be equal to, and then I'm going to do pi plus our related acute angle that we got here, but we called this a, so we'll call this a right here. So plus about 0.93, but I use the actual value of a, which is the inverse sine of 4 over 5. So this is about 4.07. So this right here is about 4.07, and let's do the same thing for U2. So here I'm going to say U2 is going to be equal to, and then we'll say 2 pi minus A, or minus our related acute angle, so it's about 5.36. But I have these values stored into my calculator because this is going to be helpful to me when I'm ready to do some calculations with these values. So then step F says to use that to determine all possible values of x this time. So this right here, we're going to do all possible values of x in one period. So essentially here, what we're going to do is we're going to pretty much undo the u substitution. So if we knew that we said that u is equal to 4x minus pi over 3, then we could say that we can add the pi over 3 to the u right here. So u plus pi over 3 and then divide that by 4 is equal to x. So based on that, we can say that x1 is going to be u1 plus pi over 3 all over 4, where the u1 is this value 4.07. But the nice thing is, I've stored this value into my calculator right here as u1. So I can say that my answer right here is going to be u1 plus pi over 3 all over 4. So my first answer here is going to be approximately 1.28. So here I'm actually going to store this in right here as x1. Okay, so x1 is approximately 1.28. And then I can do the same thing for x2. It's u2 plus pi over 3 all over 4. So I'll use that value to figure out what x2 is going to be. So I'm going to type in right here that this is going to be u2 plus pi over 3 all over 4. And so this answer right here is about 1.60. But this is how many answers we have within one period, right? So we have 2 solutions within one period. We also have 4 periods. So therefore, we're going to have 8 solutions. Right now, the only solutions that we have are 1.28 and 1.60. So step G says to add the period of the trig function to each of your 2 possible x values to determine remaining x values. So we know that x1 is approximately 1.28 and that x2 is approximately 1.60. Well, based on that, we can figure out x3 and x4 by adding a period. How big is the period? Pi over 2. So I can take x1 and then add a period, which is pi over 2, and that tells me that my next solution is going to be 2.85. And then I can do the same thing with x2. I can take x2, add another solution to that, another period to that, which is pi over 2, and I'd get about 3.17. So now I have 4 of my 8 solutions. So I'm going to add another pi over 2 to get the next 2 solutions. That's going to give me x5 and x6. And then I'm going to add another pi over 2 to get my last 2 solutions. So that's going to give me x7 and x8. So go ahead and calculate those solutions and see what you get. Make sure to pause the video and see if you get the same answers as me before you move on, just to be 100% sure that you're doing this correctly. I'm going to show the answers to the last 4 x values in about 10 seconds, so you're going to want to pause. So these are the solutions we get: 4.42, 4.74, 5.99, and 6.31. These are our 8 solutions. But then question H says to ensure all final answers fall within the domain given. And if you look right here, the domain says that it has to be between 0 and 2 pi. So right here, 2 pi is approximately 6.28, and this value is just a little bit too high. So this does not work. This is too high. So we actually have to kind of work backwards from here. So we know that our last solution is going to have to do with this baseline of x2, this 1.60. But instead of adding pi over 2, we can take that 1.60 and subtract pi over 2. So let's see what we get. And that 1.60 is x2. So I'm going to subtract pi over 2. And if you look right here, it's a little bit above 0, so it is within our domain. So it'll be 0.03. So this is our first solution. So that means that our total final answer is going to be 0.03. And then now I'm just going to go in order. So x1 is 1.28. X2 is 1.60. I better write small. X3 is 2.85. 3.17, 4.42, 4.74, 5.99, and then we've got 3, 4, 5, 6, 7, 8 solutions. So this right here is our final answer. Let's double check. If you notice here, I wrote the left side of the equation on line 1 and the right side of the equation on line 2. I want to graph them out and see where they intersect. I've restricted the domain from 0 to 2 pi. So they intersect at 0.03, 1.28, 1.60, 2.85, 3.17, 4.42, 4.74, and 5.99, which are all the answers that we got right here. So we know we did it right. Okay, that's it for this video. I hope you have a great day, and let me know if you have any questions next time you see me in class. Bye.